Ladies and gentlemen, welcome to Global Math Mentor. In this video, I will be solving CIE Further Mechanics paper for the May-June 2025 series, paper 3-2, 1 hour 30 minutes, 50 marks. You should pause the video, read the instructions, and another important thing is if you are preparing for your A-level math or further maths, subscribe to the channel so you don't miss out on any useful resource. Let's begin. Question 1. A particle P of mass 8 kg is moving in a straight horizontal line at time t seconds. P has displacement x meter from a fixed point O on the line and the velocity v. So we have a particle. It seems like this. And this is O, the fixed point, and the velocity is v meter second inverse. Right? The only horizontal force acting on P has a magnitude of x cubed plus 4x Newton and x in the direction OP. So there is a force, the only horizontal force. You can write it like this. I mean, these free body diagrams do not possess any marks. It's just for my own understanding so I can connect with the problem. When t0, x is 0, v is 1, we are given some initial conditions. Part A, find an expression for v in terms of x. Giving your answer in the form this, where A and B are constants to be determined. So we go for Newton's second law. The horizontal force will be mass times acceleration. We don't have acceleration right now, but we can use the idea that acceleration is dv over dt. And if I apply chain rule to this can be written as dv over dx times dx over dt. Now that's a useful expression if you observe. This over here is the velocity, the displacement divided by time, the rate of change, and dv over dx. And I can use this for in place of the acceleration. In order to get an expression for v in terms of x cubed plus 4x equals to mass is 8, and I can put a v dv over dx. Now this is just like a separable differential equation. I can x cubed plus 4x separate and integrate 8v dv, right? So this will turn out to be x4 divide 4 plus 4x squared divide 2. I can write 2x squared. And in place of this, 8v squared divide 2. So that's going to be 4v squared plus c. Now I use my initial conditions. So x is 0 when v is 1. So that will be 0 equals to 4 plus c. So c will be a negative 4. Now I get x to the power of 4 divide 4 plus 2x squared equals to 4v squared and minus a 4. Now the question says that I need an expression for v in terms of x, so I need to make v the subject. Let's see. And it should be a quadratic expression, whereas the expression I'm getting right now is a quartic one, right? So, okay, so I'm going to solve over here. I'm running out of space. So x4 over a 4 plus 2x squared and plus 4 will be equals to 4v squared. So v squared is going to be, that's going to be x4 over 16 plus 1 over 2x squared and plus 1. Oh, so now you see, I need to complete this square. By the way, this is a complete square, a perfect square. I can write it x squared over 4 plus 1 whole squared. Now root both sides, and I need the expression for v, and hence I will get the expression of v in terms of x, which will be, if you square root both sides, you will get this, right? So that is the first part. You can pause the video, take notes, and then you can proceed with the next one. Let's take a look at part B. So now they're saying find an expression for x in terms of t. So now I need expression for x in terms of t. Remember that v is a dx divide dt. So in the same expression, you can switch it. And let's just, I think it's better if I write it like a single expression. It's easier to separate. So this will become 4 over x squared plus 4 integrate dx and dt. So these are both differential equations. And this, you should know your integration. This is going to be 1 over 2, the arctan of x over 2, or a tan inverse of the x over 2, right? And put equal to t plus c. I can simplify. So when x is 0, I think t is 0 as well, right? So that will be good. This implies that c is going to be 0. So you can check arctan of 0 is just a 0. So I'll get 2 tan inverse x over 2 equals to t. Now remember, I need x in terms of t, not t in terms of x. So there's a little more work left. That's going to be t over 2. And hence I can write x equals to 2 tan t over a 2. And that should be my answer. Question 2. A particle piece projected with a speed of 24 meter per second at an angle theta above the horizontal from a point O on horizontal plane and moves freely under gravity at a horizontal distance 35 meter from O. There is a vertical wall of height 10 meter, which is perpendicular to the vertical plane of motion of P. Part A, determine the two possible values of theta for which P just clears the wall. It's a projectile situation at a distance of 35 meter. There is a wall of height 10 meter, right? It's a wall of height 10 meter. So a particle is projected with a speed of 24 meter second inverse. It goes like this, and there's a projection angle, theta as well. So you can either find the components, like the horizontal component, which is going to be, x is going to be v cos theta t, and y equals to v sine theta t, and minus a half gt squared. Or maybe it's better if you can use the trajectory equation given, because in any case, if I get rid of this t, eliminate t, I'll end up with, it's given in the formula booklet. So you can take a look at that, x tan theta, and minus a g x squared divided 2v squared cos squared theta. But if you have any doubts and confusions, like you want to learn these fancy results, you can comment on the video and I'll give you a separate lesson on that where I'll explain each and everything. How do you get each of these fancy projectile results, right? And which are really useful in solving problems, right? Okay, so I'm skipping this one and I'm just going to apply my values in this trajectory equation. So the vertical distance is 10. X is the horizontal distance, which is going to be 35. And that's going to be tan theta. And minus, this is going to be 10, a 35 squared, and divided by a 2v, which is a 24 squared, and cos squared theta. Oh, by the way, this cos squared theta, I can write it as secant squared theta. And like this part can be written as 1 plus the tan squared theta. So I'll get a quadratic equation and one trig function, which is a tan. Okay, so let's simplify this a bit and I'll get with 35. And let tan theta, you can call this something, k. So that's going to be a k minus, okay, let's get these values first. 10 times 35 squared divided by like a 2 times a 24 squared. Is that fine? Okay, yeah. 6125. 6125 over. I keep forgetting these numbers. 576. And that's going to be 1 plus a k squared. Okay. So now I think I can time throughout with 576. Who cares? I can use my calculator to solve this equation. 35. 20160 k minus a 6125 and minus a 6125k squared. So this will be 6125k squared minus a 20160k and plus, let's just write 5760 plus 6125. So that's going to be, I just mess up sometime while inserting values, so I'm just a bit conscious. 6125, right. 11885, 11885 and equal to 0. Well, in your actual exam, you can show actually that what you are doing. So just plug in these numbers, and so you don't miss out on the method marks. 100. So the mark schemes, I mean, sometimes it say, most of the time it says like show a reasonable attempt, 11885. So the M mark, remember guys, the M mark is important. Okay, so now I can just use my calculator to solve this quadratic equation. So go to the quadratic and carefully put in the number 6125 minus 20160. And the next one is like a 11885. So that's going to be a 2.522, 2.522. And the second one is going to be 0.769, 0.769. Okay. So K, let's bring back the tan theta. And the question says determine the two values of theta for which P just clears the wall. So this will give me my required result. Let's put the tan inverse of 2.522 and a tan inverse of 0.769. And let me check if my calculator, it is in degrees, right? So, I mean, nowhere does it say radian, so let's keep it degrees. Tan inverse 2.522. So that's going to be 68.371, 68.371. And next, I can just go back and delete this and put a 0.769. 37.560, 37.560. So I can give my final answers correct to one decimal place. Since these are angles in degrees, 37.6 degree. Okay. So that's the first part. And now we move on to the next part. They're saying, given that P clears the wall, okay, find the minimum distance from point O where P can land. Now that is a classic range question. So again, you should know these fancy results. It's like a u squared sine 2 theta divide g. Now the thing is, I need to find the range, but since I need the minimum distance, so I need the larger angle, because the greater the elevation, the shorter the range, right? Okay, so I'll be using, now watch out, don't use this one, instead use the unrounded one. So u is just, what's u? Okay, that's 24 squared, and sine 2 times, I'm using the 68.371. Keep it a bit unrounded so the final answer doesn't get deteriorated. So that's going to be the range minimum. And similarly, if they say like find the range of possible, like all the possible ranges, then you can find the upper bound and the lower bound as well, right? So, okay, so let's go 24 squared times a sine. It's going to be 2 times 68.371. Let's get this and divide it by 10. And I'm getting 39.472. 39.472, approximately 39.4 meter, right? And that should be my answer for part B. Question 3. A rough horizontal disk center O rotates with constant angular speed omega radians per second. A particle P of mass 1.6 kg lies on the disk at a distance of 1.5 meter from O and is attached to a point A vertically above O by a light elastic string. Okay? The string has a natural length of 2 meter, modulus of elasticity is 32 Newton, and makes an angle alpha with the vertical OAC diagram. We can see that particle P moves in a horizontal circle, also at a constant angular speed, omega radians per second. Particle P is on the point of slipping in the direction OP. So there's limiting equilibrium as well. The coefficient of friction between the particle and the disk is a 0.5. So plenty of information. Make sure you read the question carefully. Part A. Given that the tension in the string is 8 Newton, show that sine alpha is 0.6. So we know that the natural length of the string is 2, but it's an elastic string. So we use the Hooke's law for elastic strings. So that's going to be lambda x divide L, where T is the tension, lambda is the modulus of elasticity, x is the extension, and L is the natural length of the string. So everything is given. That's why it's just a 2-mark question. So 8 equals to, what's the modulus of elasticity? That's 32. The natural length is 2, and this is x. This will give me the extension. X equals to 8 over 16 is a 1/2. Okay. So now we know that AP's natural length is 2, but we add the extension like a half, like a 0.5. So this will give me a 2.5. Now we apply SOHCAHTOA on the right triangle. Sine alpha is going to be 1.5 divide a 2.5, which will be a 15 over a 25. So 5, 3, 5, 5. So hence sine alpha is 0.6. You can write shown, right? Okay, so let's see what's the next bit. Now they're saying find the number of revolutions per minute made by the disk and the particle P. So for this, we need to resolve. And let's see. So I can use the same diagram. Let me just make a new one over here. So there's a particle, and the string is acting in this direction. So I can say this is tension. There's obviously normal reaction. There is weight. I need to scroll up and down. 1.6. So this will look like 16 Newton. And obviously there's the total inward force, the centripetal force. So I need to resolve the frictional component, which is a mu r. And okay, let's just resolve this. So this angle is alpha. So I can make this one alpha as well. All right, that's it. So let's go. If I resolve horizontally first, the total inward force is going to be mu r and plus a t sine alpha, and that will be equal to m omega squared r, right? That's the formula. And I've got plenty of information, but let me just resolve it vertically as well, which is going to look like r plus a t cos alpha, and that is going to be 16. Okay, so let me just check. What do I have from the previous part? I have tension. Mu is given as well. That's good. Okay, let's just write it over here. Mu is a 0.5. Tension is 8 Newton. And also sine alpha, we just proved, is a 0.6, which is a 3 over a 5. That's better. So I can just write it like this, and I can use the exact values for sine and cos. All right, so we're good to go. So from this second equation, I can see that the normal reaction will be 16 minus t is 8, and cos alpha is a 4 over 5. So let's just get it. 16 minus 32 over a 5. So let's just go and get it. 16 minus 32 over a 5, which is, let's just use a 9.6 instead, right? Normal reaction. Okay, I'm going to sub it now in the first one. So mu is a 0.5. Normal reaction is a 9.6. We have tension, we have sine alpha, we have mass, which is a 1.6. Omega we're looking for, and the radius. I need the radius. Okay, that's a 1.5. Great. Okay, so that's a 1.5. So let's get omega squared first, and then I can root that. So why are we doing this? Because we need the number of revolutions. For that, we need this angular speed plus 8 times a 3 over a 5. Oh, let me just quickly check. Am I doing it right? Okay, so divide 1.6 and divide a 1.5. Oh, that's a 4. This implies that omega is just a 2. radians per second, right? Okay, so in order to get the number of revolutions, I need to apply the idea omega over 2 pi, but that's going to give you number of revolutions per second. They're asking about minutes, so let's just time it with 60 and see what do we get. So this is going to be 2 over a 2 pi times a 60. And I'm going to use my calculator. So that's just a 1 over a pi and times a 60. And 19.086, or approximately I can say 19.1 revolutions per minute. All right, that's it for this question. Question 4. An object is formed by removing a solid hemisphere, radius 2r, from a uniform solid cone, radius 3r, and semi-vertical angle, theta, where tan theta is a 1/2 the axis of symmetry of the cone and the hemisphere coincide. The base of the cone and the base of the hemisphere are in the same plane as each other. See diagram, part 8. Find in terms of r the distance of the center of mass of the object from its base. So the semi-vertical angle is given, the axis of symmetry is given. So the centers of the bases coincide. So I know that the coordinates of the center of mass will be on this axis of symmetry. And to solve such a problem, first you need, obviously, the idea is to calculate the moments for the center of mass, but I need the volume and center of mass of each of these solids and then the actual remaining solid. So let's begin with that. So I'll start with the cone. Okay. So for cone, I know that it's a 1/3 pi r squared h, which is the volume of the cone. So I don't have the height right now, but I can use, let's say, tan theta. Yeah, that's what I can use over h. And tan theta is given over here, which is a 1/2, and that's a 3r over h. So h is going to be 6r. So let's calculate the value. 1/3 pi, radius is a 3r squared, and h is a 6r. So this is going to be 18 pi r cubed, right? So now we calculate center of mass of a cone. So from the vertex, it's a 3/4 of the height. So I want to calculate it from the base, since they are saying find in terms of r the distance of the center of mass of the object from its base. So I will use a 1/4 of h. So that's going to be 1/4, and height is a 6r. So that is going to be 3 over 2r. By the way, these standard formulas for center of mass are given in your formula booklet. You can check those out in the MF19. Now let's talk about the hemisphere. So hemisphere is, you can also make table to calculate each of these values, but I'm just solving it this way. So volume of the hemisphere is a 2/3 a pi r cube, but the radius over here is a 2r. So 2r cubed, that's going to be 8 twice 16 over 3 and pi r cubed, right? And the center of mass, the formula given for the center of mass of a standard hemisphere from the base is going to be 3/8 of the radius. So that's going to be 3/8 of 2r, and that's the 3/4 of r, right? Now we calculate the volume of the remaining solid. So the remaining, the actual one, by remaining, I mean when the hemisphere has been taken out of the cone. So that's going to be volume of the remaining solid is going to be 18 pi r cubed, and take out a 16 over 3 pi r cubed. So let's calculate this. 18 minus a 16 over a 3. So this is a 38 over a 3. Let's call this 38 over a 3 pi r cubed. And the center of mass of this remaining solid is just going to be y bar. That is what we are looking for. Center of mass of the object from its base. Okay. So now we use the moments idea for the center of mass. So we use the masses, but since it's the same solid and you know the idea of the density, so we can use volume in place of mass when the densities are equal. So how does it go like? We know that we need volume of the remaining solid into center of mass of the remaining, and like the sigma V and C. But you can just do the sum of volume of the cone, center of mass of cone, minus volume of the hemisphere minus the center of mass of the hemisphere. So that's the moment rule. And I can use 38 over a 3 pi r cube and y bar here equals to volume of the cone, which is a 18 pi r cube, and the center of mass is a 3 over 2 r from the base, minus hemisphere, where did it go? Okay, 16 over a 3 pi r cube, and a 3/4 of r. So let's just get rid of the pi r cubes, and I'll be left with 38 over a 3 y bar equals to, that's going to be 9 3s are 27 r. And this is going to be minus a 4 r. So that's just a 23 r. Oh, I don't have space, sorry. Y bar, that's going to be 23 r times a 3 over 38. And that's 69 r over a 38 y bar. So that should do, right? Okay, so let's begin with the next one. My working was a bit clumsy, but I hope you can pause the video and just go over this concept again. Okay, so let's begin with the next one. That's the object is placed such that its circular base makes contact with a rough plane, which is inclined to the horizontal at an angle alpha. The object is on the point of toppling. The plane is sufficiently rough to prevent sliding. Find the value of alpha. So now we have is we can sketch it like there is an inclined plane, inclined at alpha, and the solid is like here, like this, right? And the crucial part is, since it's just sufficient to prevent sliding, the center of mass, I think I should make it a bit differently. I must show the idea that the center of mass, the weight should act in the line where this edge is, like, you get it? So the line of action of weight should pass through the edge of the base of the cone, because any angle which is greater will cause toppling, right? So this is it. Sorry about that. So I just wanted to make it like that. So that's the idea. This is where the weight acts. And now we need this angle. So this is alpha, and you can check that. So, oh, it's a bit clumsy drawing, but you get it. Like, this angle is going to be alpha as well. You know why? Because this is a 90 and that's a 90 minus alpha, and the vertically opposite. I mean, you can zoom it and make it again and check this out. All right, so this is a y bar. That's the y coordinate of the center of mass, which we just found. And this is, I can check that. That's the radius. So that's going to be a 3r, right? So you can read the statement again. Why did I make the line of action of weight exactly from the edge of the base of the cone, that's solid? So the plane is sufficiently rough to prevent sliding. So I just need this angle. So let's go with tan alpha, and that's going to be 3r divide a y bar. And y bar is a 69r over 38. So 3r over 69r divide 38. The r's cancel. So this is just going to be, so 3 divide a 69 over 38. You can just multiply with 38. So that's going to be a 38 over 23 tan alpha. And alpha is going to be tan inverse of a 38 divide 23. Okay, so let's do the shift tan inverse answer. And I'm getting 58.1815, 58.815, which is correct to one decimal place, 58.8 degrees. And that's it for the question. Question 5. One end of a light elastic string of natural length, 0.5 meter, and modulus of elasticity is 14 Newton. So let's just write it down, these information given. So natural length is given, the modulus of elasticity is given. Okay, is attached to the fixed point A. Okay, so the string is attached to a point A on a smooth plane. The plane makes an angle alpha to the horizontal where tan alpha is 7/24. So I would like to make a triangle 7. This is 24, this is alpha, and that's going to be a 25. You can check that. A particle P of mass 2 kg is attached to the other end of the string. Okay, the string lies along the line of the greatest slope of the plane. The particle P is initially held on the plane above the level of A, where AP is 0.8. All right, so this is a situation now. There's an inclined plane, there's a point A somewhere, and there's a particle attached to the other end above the level of A. So this string is making is parallel to the line of the greatest slope, and this is 0.8 meter in length. So already we can see that there is extension of a 0.3 since it's an elastic string. The particle P is then released from rest. So it starts moving now. Find the maximum velocity of P during the subsequent motion. So when the particle P starts moving, it will definitely go to the other side, and we're not sure like how stretched this will be then, but we can check that since it's the maximum velocity which we are trying to get. So we know that the acceleration is going to be 0. So the net force is 0. So tension will be equal to the weights component down the plane since it's inclined at alpha to the horizontal. So that's going to be 2g sine alpha. So that's the particle's weight. All right, so let's put t equals to 2g sine alpha and check this value. That's going to be 20 times a 7/25. All right, so let's get that 20 times 7/25. And that is, let's write a 5.6 Newton. All right. So now using this tension, I can find the extension in the string when the particle is below the level of A. So for that, I use the formula T equals to lambda x divide L. So tension is a 5.6. And the coefficient, the modulus of elasticity is 14. And the natural length of the string is 0.5. So let's calculate this as well. 5.6 times 0.5 and divide by 14. So I'm getting a 1/5, which is just a 0.2. This means that below the level of A, the string's length will be 0.7 meter. All right? Okay, so now how do we calculate the velocity? We're looking for the maximum velocity. So we need to figure out all the energies in the system. So initially, let's just check initially what's going on. No kinetic energy, but the potential energy at the top, let's call this T, is going to be mgh, which is 2 times the 10 times the h. And h is going to be just a 0.8 sine alpha, right? So we know that height can be calculated using sine theta or sine alpha. That's a 20, or you can say 16 times the 7/25. So I'm going to calculate this value, which is going to be 16 times the 7/25. And that is a 4.48 joule, right? Okay, so now we figure out what is the elastic potential energy at top, right? So for that, I used lambda x squared divided to L, the formula. We need to check 14 is the modulus of elasticity. The initial extension, you can check that the initial extension you can give like a 0.8 minus a 0.5, which is a 3, x in this case. So that's going to be 14 times a 0.3 squared and divided twice a 0.5, which is just a 1, okay? So I can do 14 times a 0.3 and square it, and that will be a 1.26 joule. All right, so I have calculated the energies, the potential and energy, the elastic potential energy at the top, and no kinetic energy, right? Now we talk about like finally what's going on at the bottom. So that will be like the potential energy at the bottom. Let's just calculate that. That's going to be mgh again. But this, since it's below the level of A, so I'm going to be using a negative mgh, 2 times 10 times a height, which will be a zero point 0.7 sine of alpha. So you get it? Why am I using the negative sign? So that's going to be a 14 times a 7 over a 25. And this will give me 14 times a 7 over a 25. And that is a negative 3.92. Negative 3.92 joule. And again, the elastic potential energy, it does not depend on the sign like above or below. It just depends on the extension. Okay, so that's going to be lambda x squared over 2L again. So no negative sign is going to be 14 and times this time the extension we just calculated is a 0.2 squared and divide by 2 times a 0.5, which will just be a 1. So let's calculate this 14 times a 0.2 and squared, and that is a 0.56 joule. 0.56 joule. So if you have any doubts, confusions, pause the video, look at each of the possible energies I'm calculated, potential energy, elastic potential energy. Initially, there's no kinetic energy since the particle started from rest, but finally, we're looking for the maximum velocity, the top velocity, right? So the kinetic energy at the bottom is going to be a half mv squared. So half times m and times a v squared, and that's just going to be a v squared. So by the conservation law, oh, thank goodness I have space. I can put all the energies initial equals to energy final. Let me put just a sigma. So all of the possible energies. Initially, that's going to be 4.48 joule plus that's going to be a 1.26 and equal to a negative 3.92 plus a 0.56 and plus a v squared, right? Okay, so let's just calculate. It's too many decimals. We got to be careful while inserting them in the calculator. Plus 3.92 and minus a 0.56, right? Let's go. Square root answer. And this is going to be 3.0166, 3.0166 meter second inverse. And I can write 3.02 meter second inverse, the final answer. That's V max. And that's it for this question. Question 6.2. Uniform smooth spheres A and B of equal radii have masses 2m and m respectively. Sphere A is moving in a straight horizontal line with the speed of u, and sphere B is stationary. So let's just make a diagram. So we have sphere A, mass is 2m. We have sphere B, the mass is m. This is moving initially with the speed of u. This one is stationary. The saying sphere A collides directly with B, and they both then move in the same direction with the speeds VA and VB. So this is VA, this is VB, respectively. After collision, the kinetic energy of B is 9 over 2 times the kinetic energy of A. Part A, show that V sub B, the means the velocity of B is 6 over 5 U. Okay, so kinetic energy of B is a 9 over 2 times the kinetic energy of A. That is one situation. Let's just get this because they're saying after collision. So I am not considering the whole thing. So it's just after collision. So half M, that's just the M, and V squared. And this is going to be 9 over 2 times a 1 half, a 2M, and a V sub A squared. So what do we do? Let's get rid of these 2's, like times both sides with the 2. This will be MVB squared equals to, let's get rid of these 2's as well. 9 M and V sub A squared. Divide both sides with M. And now I can just square root and I'll get VB equals to 3VA. Let's call this equation 1. I need another situation now because I need to get rid of this VA. So from the conservation of linear momentum, we know that momentum before collision will be equal to momentum after collision plus M V sub A. Divide throughout with M. 2U is going to be 2VA plus, oh, my bad, that's going to be VB. VB. All right, so let's make VA subject. That's going to be 1/3 of VB. If you sub it here, that's going to be 2/3 VB plus VB. And this is going to be 5 over 3 VB. So in order to make V sub B subject, times both sides with a 3, 6, that's going to be 5 VB, 6U, and hence VB will be a 6 over a 5U. And that's it for part A. This is shown. Okay, sphere B then collides with a fixed vertical barrier. Immediately before the collision, the direction of the motion of B makes an angle alpha with the barrier. All right, so this is an oblique collision. So they are saying there's a vertical barrier, and this is B, and it hits the barrier and makes an angle alpha with the barrier. Immediately after the collision, the direction of motion makes an angle beta with the barrier. So it will definitely go here somewhere. I'm just making this up. This is beta. So this is a situation now. The coefficient of restitution between B and the barrier is 4 over 5. So we know that the coefficient of restitution is the speed of separation divide the speed of approach. So in this case, you can observe that the vertical component, or you can say the components along the barrier, like parallel to the barrier, will stay the same, right? They will stay the same. So in this case, I should just put, okay, I need the velocities over here. So we just proved that this is a 6 over 5U. And this one is, they're saying as a result of the collision, the velocity of B is reduced to this. Okay, so that's a good thing. I've got the velocity expression as well. So let's just put the vertical components equal. That's going to be 6 over a 5 U cos alpha will be equal to a 12 over 25 root 5 U cos beta. So remember, these are these components, right? Okay, so let's just simplify it a bit. 5, 5, and 6 double. That's going to be a 5 cos alpha equals to 2 root 5 cos beta. Okay, so I am looking for the compound of sine of alpha plus beta. So I need each of these sine alpha, cos beta, cos alpha, sine beta. So let's just make this equation 1 for now. And now we use the coefficient of restitution. So in this case, this will be the speed away from the barrier divided by the speed of approaching, which is towards the barrier. And this will look like 12 root 5 over a 25U and sine of beta. And divided by, this will be 6 over a 5U sine of alpha. Okay, let's get rid of this. And 24 over 25 sine alpha. I just cross multiplied. 12 root 5 over 25 sine of beta. Let's get rid of these 12 twice. So I'm getting a 2 sine alpha equals to a root 5 sine of beta. Okay? So let's call this equation 2. All right, so, oh, thank goodness. I've got some space to work. We need to get each of these, so let's square 1 and see what do we get, and square 2 and see. So that's going to be 25 cos squared alpha equals to 4 5 times 20 cos squared beta. That is one situation, and this will be 4 sine squared alpha equals to 5 sine squared beta. So you can work this out anyway. Let's just use this one maybe, and 4, and I can put a 1 minus cos squared up alpha. And this way I can put, let's make cos squared alpha subject, and then I can substitute in that one. So 1 minus cos squared alpha will be a 5 over 4 sine squared beta. So 1 minus a 5 over a 4 sine squared beta will be cos squared alpha. Okay? So let's just put it over there. So 25 cos squared alpha, which will be obviously a 1 minus a 5 over a 4 sine squared beta. Hactic equation 20, and let's put this as well, 1 minus sine squared beta. So this will help me get sine squared beta, and then I can find everything else accordingly, right? Okay, so let's just put 5, 5 and 5, 4. Yeah, that looks better. 5 minus a 25 over 4 sine squared beta equal to 4 minus a 4 sine squared beta. So that's going to be 5 minus 4, and this is going to be 25 over a 4 minus a 4 and a sine squared beta. And that's going to be 25 minus a 16, which is a 9 over a 4 sine squared beta. And hence, sine squared beta will give us 4 over 9, which will eventually cause sine beta equals to a 2/3. Let's just box this. Okay, this is now going to give me 1 minus a 5 over 4 times a 4 over a 9 for cos squared alpha. So cos squared alpha is going to be a 4 over a 9. So cos alpha is again a 2/3, right? There we go. And now we need to figure out what is sine alpha. So that for that I can use that top equation. So 4 sine squared alpha will be 5 sine squared beta, which is a 4 over a 9. Let's get rid of these. And sine alpha then will be root 5 over a 3. Let's box this as well. And I can use cos alpha and that equation, this one. So why didn't I simplify it? 5, 5, and 5, 4. That's going to be 5, and a 4 over a 9 equals to 4 and a cos squared beta. 4 cancels 4. So cos beta will be a root 5 over 3 as well. Well, bingo, here we go. Sine of alpha plus beta is going to be sine alpha, cos beta, which is a root 5 over 3, and plus a cos alpha. Oh, wait, have I messed up? Sine alpha, cos beta, yeah, plus cos alpha and sine beta. That's it. That's going to be 5 over a 9 plus 4 over a 9. Well, that looks good. 9 over 9. So I'm getting a 1. Oh boy. And that's it for this question. Question 7. A fixed hollow sphere has radius A and center O. The points A, B, and C lie on the inner surface of the sphere with OA and BC horizontal. We can see OA and BC horizontal. A portion of the sphere has been removed by a horizontal cut through B and C at a vertical distance KA above the center of the sphere. So there's a cut made here where K is a positive constant and K is less than 1. The points O, A, B, and C all lie in the same vertical plane. So OB makes an angle theta with the upward vertical through O. See diagram. I can see that. A particle P of mass m is free to move on the smooth inner surface of the sphere. The particle P is projected vertically downward from A with the speed of u and begins to move in a vertical circle. Okay, so this is a vertical circle question, and we can see there's plenty of information. This is the base levels. A particle is thrown here, projected with the speed of u, and it reaches B. So they're saying part A, in the case where u is this, 6/5 GA root, the reaction on P at B is half the reaction on P at A. Find the value of K. So with these kind of vertical circle questions, there are two things that need to be considered. First is the Newton's second law, and then the second is the energy. That's what we will look into. So the reaction here, okay, that is the reaction at A, and that's just the net inward force, and that is going to be MA, but I will use V squared over R. So radius is A and the velocity is U. So M U squared over A. That is the reaction at A, okay? Now consider the reaction at B, but this is slightly above the level of A. So I need to consider the weight component as well, like this. And I can make a diagram like this. And this is going to be theta. And that will be theta as well. You can check that. So the reaction here at B, I can write it that R of A plus mg cos theta will be equal to m and v squared divide A. Okay? So let's make the expression R of A will be mv squared over A minus mg cos theta. But cos theta, I can check from this triangle that here cos theta is just a Ka divide A. So that's just going to be a K. Well, that's good. So I can put a K over here. So that's it. So now I equate the reactions. There's plenty of space. I know that they're saying that the reaction on P at B is half the reaction. So it means that reaction on B will be half the reaction on A. So let's use this idea. This is going to be mv squared over A minus mgk. And that is going to be half of mu squared divide A. And I've got the value of u. But before that, let's just simplify, divide throughout by this. V squared over A minus gk equals to 1 over 2a. And I can put the u squared, which is a 6 over a 5ga. So let's get rid of these a's, and 2 3s or 6. So v squared over a minus gk is going to be 3 over 5. And is that just a g? Okay, yeah, that's it. Okay, so let's call this equation 1 and let's simplify the energy portion and see what do we get out of it. Remember, I just need K, okay? So for the energy, so this is the base level. So initially, you can say the energy, okay, let's just write it here. Oh, what did I just say? Yeah, that's a 1. I can just say that the energy initial is just going to be 1/2 mu squared, the kinetic energy. But the energy final, on the other hand, is going to be 1/2 mv squared. And there will be a gain in the potential energy as well, which is mgh, but I'm writing a Ka since I can see the height is a Ka. Well, energy initial is energy final, so mu squared is 1/2 mv squared. And plus mgka. Let's just simplify this a bit as well. And what do? I can put the u square and half. That's a 3/5 of a GA. I squared it and then divided by 2, right? And this is going to be v squared over 2 equals to gk, plus a gka. So what should I do about this thing? I can use this equation to make v squared the subject and then sub in the value, right? That should be good. So 3/5 GA minus a GKA times a 2 is a V squared, right? So let's sub it over here. Let's call this equation 2. So if you sub 2 in 1, that's going to be a 1/A 2 times, or I can just multiply this 6/5 GA minus a 2 GKA. Okay? And this will all be minus GK equals to 3/5 G. That should do. Okay, so this will become 6/5 G minus a 2 GK. Reason the A's cancel. And minus a GK equals to a 3/5 G. Oh boy, what should I do now? Oh, G throughout. Let's get rid of these G's, right? So 6/5 minus a 3K equals to 3/5. Oh, I still have space. So 6/5 minus a 3/5 will be a 3K, and 3/5 is a 3K. Let's get rid of these. So K is going to be a 1/5. All right, so that's it. That's for the first part. So remember, in a vertical circle, the key ideas are Newton's second law and the energy perspective, right? Okay, so let's take a look at the next bit. Part B, find an expression for U in terms of A and G, in the case that the particle just reaches B. Oh, that's a crucial idea. So the moment it just reaches B, we take the final velocity 0. So what should we do? We can use maybe one of the equations that we have already. What do you want to go with? Let's do the energy equation. Okay. So let's say u squared over 2 will be equal to, that's going to be a GKA. So GKA, right? And K is a 1/5. So U squared is going to be 2/5 GA. And hence, this implies that U is just going to be the square root of a 2/5 of a GA. And that should do, right? Okay, so this is another one. They're saying find an expression for U in terms of A and G in the case that the particle passes through B and in its subsequent motion reaches C. Wait a minute. Didn't the circle just ended over there? Okay, so this is now a projectile question. So your particle jumps from here like this, and all the way to reaches C. And this angle is a 90 minus theta, and 90 minus a 90 minus theta. That's a good thing. This angle is going to be theta as well. So let's just make a separate diagram for that one. So this is point B, and the particle reaches point C in the subsequent motion. So from here, let's just say it leaves with a velocity of v, goes all the way like this. Okay? So we need the expression for u, right? And for that, obviously, but first we need a method to get v. So what do we do now? Let's take a look at this horizontal distance, which is just, okay, so that's going to be a sine theta. You can check that in this right triangle. So this will be a sine theta as well. Symmetrical. So this is going to be a 2a sine theta, this horizontal distance. Okay, so we know that the horizontal distance is just going to be v cos theta into a t. So now I need a method to get this value of t, and that can help me get the expression. Okay, so how do we get that? Okay, so we can use the vertical displacement equation, but that's just going to be 0 because the particle reaches c. So let's just do it. Y will be a 2v sine theta. Wait, that's just going to be a v sine theta t and minus a half gt squared. So put y 0, so v sine theta t is going to be a half gt squared. So what do we do now? We get rid of one of the t's. So t is just going to be 2v sine theta and divide g. So let's sub it over here. 2a sine theta and v cos theta times the 2v sine theta divide a g. So what can we do? We can get rid of the sine theta and the 2's, and that will give me ag over a cos theta equals to a v squared. Okay, that is crucial now. Now I can use the same energy equation. So how can we use the energy equation? So initially half m v squared will be equal to a half m u squared, like when it reaches this region, right? And okay, so there is a potential energy, but below the level of this line BC. Oh, that's a crucial part as well. So this is below the level of BC, so I can put a minus mg, a Ka. Okay, so let's go and get rid of the m's, and I can put ag over a 2 cos theta, and cos theta is just, remember, that's just a k. That becomes a k. So that's a u squared over 2 minus a gk a. So we have k. We know that that's a 1/5. So that's going to be divide by a 1/5. It's going to be 5 over a 2 ag plus, that's going to be a g. Okay, that's a g over a 5a, right? Equals to u squared over 2. Oh, that looks horrible. G over 5. Yeah. So that's going to be, I can just use the calculator to get this value, 5 over a 2 plus a 1 over a 5. That's a 27 over a 10. Okay, 27 over a 10 ag, and that's a u squared, time it by 2. So u is going to be 27 over a 5 ag, and root that. I mean, that looks a bit weird, but 2 over 5. Well, 2 that's a 5 over 2. That's correct. I'm just quickly checking. What have I done? Plus that. All right. So that should do. And that's it for this exam. It's finished. And I hope this walkthrough really helped you. And I will encourage you all to like, share, and subscribe to this channel if you want to prepare well for your CIE A-level math and further maths. Keep following for more useful resources. This is Global Math Mentor, over and out.